So today, basically, I'm going to try to share with you how at Macy's we use advanced analytics and for our various analytics and data solutions and analysis. And I also talk a little bit about our various projects. And I also want to discuss, why modeling platform vendors like H2O is a very good fit for our type of business, and hopefully you'll find some that interesting. And first of all, I just like to say that it's a great conference, and I really enjoyed every minute. And finally, I see there are lots of people that think like me. That's very, very exciting. And that's the button? Yes. Thanks. And I like to thank Sri for organizing the conference and for inviting me to speak. Yeah, please. So I'm going to describe a little bit about our team and our main projects and how we use platforms, modeling platforms, how we optimize our business using the cutting edge technology and big data. So first of all, I think even the earlier panel, people talk about what type of data scientists there are, and everybody have their own definition. Mine is, I think there are two big categories, I would say. One is the scientists of the data, for the data. These are the people who try to collect the data. They built the platform, built the pipeline, and then the pipes so the data can be accessible and organized in a way that can be analyzed. And then you have the domain experts. These are the scientists trying to solve the marketing problems, the healthcare problems, the financial optimizations. And then they actually use data, and to do science. They're data-driven scientists. So we pretty much see us at Macy's, the data science, primarily we are the domain experts. We're trying to solve the marketing problems, the customer relationship management problems, the merchandising problems, and all that. Again, I think I concur with the speakers here. Is data is not really big data is not really about data. It's about big analysis. Big data is about big analysis and big solutions. And those big analysis, big solutions requires that we use big data. And as the field develops, I can see that, obviously, people need to specialize, and nobody can do everything. And sometimes I see this naive notion that the data scientist, is a unicorn that will do everything. And eventually, first of all, there are fewer and fewer unicorns, and also as the field develops, and you have to specialize, have to focus. I think focus is good, So the big data modeling, there's some challenges. The modeling needs to scale. And first of all, we have bigger data sets. And also, as we build more and more models, we want to build more models that are more timely, And if we only have, a few thousand, small data and takes months to build models or years to build models, we can only capture the long-term behavior. But if we can build models, very quickly, then we can find patterns that are valid only for a week or, a few days. And also, I want to talk about, it really takes time for the organization to adapt to the model decision, culture and environment. And then test and experimentation. I think earlier in one of the talks, people, ask what kind of science are we doing? There's no there's no first principle science, and it turns out, unfortunately, those Newtonian, mechanics, the electricity, Maxwell equation, and quantum, all the easy things has been done. And it's not easy to do those first principle sciences. And also, first principle sciences, Newtonian mechanics, it tend to be very, very simple. And at that time, we have no way of handling large amount of data. Now with the computer and the Moore's law, and we do have a lot of data, and that opens up the field where the system is very complex. And you can have theories. And absolutely true, theories allow us to think clearly. And we do need to think clearly. But a lot of the good, reasonable assumptions often is not true. And it's great, actually. We can use data and we test these things. I think that this is, the strengths of this field, I would say, not being able to write clean math formulas, and that's exciting, and that's revolutionizing, every field from, social sciences to medical, marketing, not at least financial as well, and even national security and government. So these are some of the solutions. Since data are so big, we do need to have data warehouse and analytic platforms that scale really well. And I also want to talk about, separation and concerns, and also scalable modeling tools and best practices. So I think if any slide, I think this slide I see is very, very important. So on the top, we have solution complexity and data complexity. Those are the things that a vendor like Macy's would need to own. That's your data, that's your business, that's your strategic advantage. You don't want to outsource those. And then in the middle, we can see there is a variability of requirements. There's standard data mining algorithms, and those I think we want to own some of that, but also we like to have vendors and scientists like H2O, like the Stanford professors, Professor Boyd, Professor Tipshani, and to have those standard algorithms so that we can use, and we can focus our domain solutions. And then, of course, lower that, we have the availability, reliability, scalability, latency, CPU, and all other things. Those belong to platform engineering, and we don't want to be in that business. It is far better to let vendors do once and then amortize over many, many clients than us to reinvent the wheel. So I can see on the left, going up, that's more and more what I call data science, and then on the right side, more and more that's platform engineering. And here we can clearly see, and maybe, my team that is it's owning the solution complexity and data complexity. And at the bottom, we can very much see, Cliff, and right. And in the middle somewhere, we can see, Professor Boyd. And somewhere in between, we can see Amy, right? That help us to build that solution. And so test experimentation, I think I talk about basically the theory may or may not be right. It's very important to think clearly, but let the experiment to decide what works, what doesn't work. In the end, we are very practical. We need to, no matter how beautiful the theory is, if we don't see the lift, if we don't see the ROI, we need to try something else. So yes, this is, I think I discussed a little bit on the panel, basically. It's not just the data science team, and we need to work with various teams at Macy's, make sure all the right data are collected. In the end, only the data scientists know actually what actually is missing, what is required, because we build the models, we test them, and we find out. And also on the other side, in order to interact with the customers, we need the creatives, we need the message, we need to buy this media, and those operational side, they need to adapt to the model decision environment, model decision mechanism or culture. And so it takes time, for example, the creatives, it just takes time for the teams to produce, to accumulate, and then we have a lot of messages. Then we can say how we differentiate the customers, and then do personalization. If you don't have a lot of messages, no matter how many models you build, you can't do much, and you're not going to see business impact. So this is, I think, I'm preaching to the choir. Basically, these are the technologies that are in the modern statistical computing, machine learning algorithms, out of sample testing, cross-validation, So basically, we want to scale. We want to build more models and high-quality models. We can't just build models that are, that are not very accurate. And also, we cannot hire an army of modelers and to build hundreds of models or thousands of models. So we have to rely on these machine learning tools and, and to help us to scale. So best practices, I think it's, again, I'm probably repeating some of the speakers here, is that it's really important to understand how the data are collected and what data can or cannot be collected. And we need to balance the cost of collecting additional data and optimizing models. If you can collect the smoking gun and your modeling becomes so easy, if it's very inexpensive to find the data, then why spend all the time optimizing models? But if we cannot collect that data, or we don't have the the regulation would now allow us, then we have no choice but to optimize models. And yeah, so basically, the rest of the processes of these, we have hypotheses to test, and we do simulations to see if the changes are reasonable. And also, never forget, I think it's very different from the academic world. We like simpler ideas. Good ideas may not be complicated, and never overlook the simple solutions. If simple solution is good enough, you can go market so much faster, and the organization will grow, will adapt with you much faster than if you have a very detailed, lengthy research and that people have a hard time understanding. Just imagine, if our partners understand logistic regression, understand decision tree that much better, it's far easier to explain random forests and GBM and deep learning. And so I would say, for us, it's very important to focus on the domain knowledge and not just the data mining tools. For us, yeah, I agree with Professor Boyd, is a lot of time is not our business. We use these tools. And I would just add a little bit, we do need to understand the nature of these tools, where they do well, where they don't do well. I'm going to skip some of that. So basically, some of our projects are customer acquisition and retention. So you can see, and these are our real-time site recommendation algorithms. At the end, you can see there are similar products, there are complementary products, and these are driven by edge-based base currently, and we very much look forward for other in-memory platform that's available. So again, we use association rules, we use collaborative filtering, and for us, these are just different representations of the similarity. And actually, we add business rules, we optimize, and we can see that for some products, actually, cross-sell, works better. For others, upsell works better. And so that's the recommended product at the end. And also we do segmentation. We have millions and millions of customers. And we can segment them into different ways. And that could be using demographic or socioeconomic, could be behavioral, could be values and style, could be channels preference, and could be brand. And we also have a lot of products, being sold and a lot of market basket. And we can build actually social networks of products being sold. So each bar, each edge will represent that these two products actually being sold together, being bought together. And that tells us something about the products. Some products are much more, have a higher degree node than others. So all these information can help us understand demographics. So certain demographic would prefer certain group category of products. That could be style, could be size, and could be brand, could be price range, could even be seasons. For example, fur, hats, and mittens. And there are these relationships among the different products. And text mining, and we can find, through text, similar products. We can either find associations. We can also dedupes. We don't want to recommend products that are too similar, for example. So there are lots of ideas. So here we have a regular email that we send, and here is a big, tall email. And we want to build, models and to see who should get what. So we used past 2 years of data, and we try to predict in the next 4 weeks, this person will buy whether the regular men's clothes and or big and tall. So here we have the purchase data, online, in-store, browse, email, response, and demographic data, store proximity, whatever the data we can get. So, and then we try to predict, so we're expanding our models. We want more differentiation as we have more creatives. So some models are more accurate than others, and that's actually pretty interesting. And it's very easy for us to model more popular products. Here I put a banana there, and it's harder to model unpopular, very niche products. I put a durian there, and when we have a big array of model scores, we need to make decisions, and that decision needs to consider not only the model scores, but also the errors, the model errors, and also the priors. And it is a balance between differentiation and noise. So here is the, I think about 1.5 or 2 years ago, I think, when I first heard H2O's talk at San Francisco meetup. And about more than a year ago, when I saw, again, a demo by Sri that 100 million rows and 50 columns and a logistic regression on 16 nodes in AWS cluster, it finishes in something like 10 seconds. I just stood up and told Sri, I can do something with that. That kind of turnaround time is like several order of magnitude higher than, faster than others. So we see ourselves as producing challenging user cases for H2O, and H2O help us to improve our customer, recommendation, relevance, and all that. So we have 15 research, nodes cluster, and we have a sample of about 7 million, and we have a very wide data sets, 4,000 and more, and mainly because our products are so complex. And in our test runs, we have 100 models, and we use through the R interface. And the model training takes about 2 days. And we measure the accuracy of ROC, AOC. So we don't look at the individual model. We look at, as a whole, are the models better? And the answer is yes. And we see improvement both in the means of ROC, AOC, but also significant reduction in the standard deviation. That means, as a group, the model is doing better. We also score, customers and working with Amy and many times, and right now it takes several hours. We're still trying to do better on that. Yeah, it's going down. Good. So I think, in terms of recommendation, I would say here, there are two aspects, and you can see this is the complexity. That's why we don't necessarily, want to focus on developing the algorithm. So on the one side, you can see there are people that are their intrinsic needs. That's me, that's in their DNA. And for those people, they are looking for value. They're already familiar with the products. They're looking for deals, and so it's easier to build a profile for those customers. But more importantly, actually, is recommend something that people are not familiar. And that's a much more challenging one. Here you can see that could be their aspirations, their social needs, their neighbors, their friends, their family are doing something, they need to do something. Trend, hot, and be respected, accepted. They want to be somebody, and they want to learn, they want to explore. It's a serendipity process, and they're more willing to risk taking. That's where they're more willing to be influenced, and that's the importance of marketing. And so finding someone like something, that's easy. Find something that somebody will like, that's hard. And that's very much our focus, freshness and newness and new product. For example, code start, we talk it again. I think that's mine. My time. I run out of my time, and I'd be happy to. Do I have time for questions?
Unfortunately, out of time, but I'm sure Daqing will be happy to answer the questions on the floor if someone has.
I'd be happy to do that. Thank you very much.
Thank you. Warm round of applause.